Check one. Check. Check one.
Good morning. Yes, sir, come here. Sir, when we make it in, yes. Right? Okay. So we are starting something important and interesting. That is fields. Right? Fields. Let's start from the regular question. That's how I start lessons. What's the first question? What is a field? Very good. What is a field? What do you know about a field? What kind of fields you have heard about? Sorry? Kian. Yes. What kind of field? Paddy field. දැක්කනේ එකෙනා පුරුදු තැන. නේද? ඒගොල්ලෝ වැඩියෙන් දන්න තැන. නේද? Paddy field. Right? Yes. අපි එතනින් පටන් ගමු. What is a paddy field? Why we call it a paddy field? What's the most important feature of that part field here? Don't think about physics. Just tell me about the paddy field. Why do you call that a paddy field? Don't use the word area as a physics student. Area is a physical quantity. A land. Is it because of land we call it paddy field? No. Why? Why it is a field? Why it is a field? Now I'm asking why it is a field. Is it because of collection, as you think? Okay. All right. That's giving a little bit of idea. I like that one. Like, for an example, paddy field is a region, a boundary which consists paddy. So the key idea we get there in this particular case is the region. There is a region, defined region. That's what she tried to tell. What? Mentioning area. They have that, domestic mindset. Area is not something measured in two-dimensional plane in square meters always. The regular meaning is what? Area. This is my area. Against saying, this is my area. How many square meters? ගුටි ගන්න වෙන්නේ නේද? ඒතර area කියලා කියන්නේ මේ not that because it is measured in square meter for two-dimensional plane. Right? But area gives you that idea of the region. We call it region better. Region. Space, I don't like much, but I like it in terms of physics. Yes. Space. Right. AC temperature kiyek තියෙන්නේ? 23 නේ මේවා නේ? Kelvin 0. Right. I'll better check. Right. So anyway, now it is a field. It is a field. Region. Region. Right. Now, paddy field is a region with paddy. What else? What are the other fields you have heard? My God, okay, some physics fields. She's talking about physics fields. Electrostatic field, magnetic field, gravitational field. Too much of physics, but yeah, okay. Before physics, soccer field, cricket field. We usually don't call golf field, do we? No, why not? Huh? There is no specific boundary. That's my point here. Soccer field, you only have to keep the ball, play inside the line. So, field is a defined region. Very good. So, under that, yes, we have three popular fields. A gravitational field, electrostatic field, and magnetic field. So gravity, unit number 5, we have done once, and we are going to do it again in March with sometimes end of this month with 2027 people. Again, one more time. And electrostatic field is the lesson today. Electrostatic. I like this, to learn this with the terminology. Electrostatic. There are two things. One, electro. The other part, static. Now, by electrostatic itself, it says, what is static? What is static? Huh? No motion kind of an idea. Yes, static idea, stagnant, remain in one place. Yes. Electro. What is electro? Older days it's not only the negative, it is the charge. Yes, either positive or negative. Positive or negative. Electro, because electron was the charge they knew. Electron, excess electrons, negative. Then deficit of electrons, positive. Yeah, there is a fair reason behind that as well, because electron is the particle, we can keep it isolate out of the structure, right? I mean, nowadays it's modern physics, modern science. We can take protons, we can extract protons out. Yes. Earlier protons were stuck inside what? Huh? Stuck inside the nucleus. So it is not considered as an individual charge. So the positive and negative. Positive and negative. So I'm not supposed to go for that, the tiny details and the your grade 6, 7, 8 class idea. So how you have experience, how do you experience static electricity, negativity, positivity, availability of charge. පොඩි කාලේ කරපුවා මතක නම් කියන්න බලන්න මොනවද ඔයගොල්ලෝ කරේ වට කියලා. හරිනම් ඒවා අපි කරන්න ඕනේ කියලා කියනවා දැන් ක්ලාස් වල අපිට කියනවා කරන්න කියලා. මොනවද අපි ඔයගොල්ලෝ කරලා තියෙන පොඩි කාලේ? ඔළුව අත ගහනවා. විතර? Yeah, plastic, ruler, dry hair. ඒවා අපි පන්ති කරන්න ඕනේ නෑ. දැන් ඉන්නේ මේ එක්සෑම් එකට මාස 6ක් තියාගෙන නේද? රූලර් කොහොමත් ඔළුවේ අතුල්ලා තමයි ඉන්නේ මේ ඔළුව කල්පනා කර. Right? So when you rub a plastic on dry hair and the small piece of paper attracted to it, balloons. ඒ පොඩි එක්ස්පෙරිමන්ට්ස් කරලා පෙන්වන්න ඕනේ වාට හරනම් electrostatic field එකක් තියෙනවා කියලා. So that is number one. But we go beyond that to a different level. Different level of work. මොන වගේවද? Ancient physics. So 1600 to 1700. අපි නිකන් scientific line එකේ යන්. අපි ඉන්නේ A level hinda 1600 to 1700. Concepts built. What do you know about positive and negative charges? You all know from grade 6, 7, 8. Dhanne okay. Tell me something you know about positive and negative charges. My God, I feel like I have to start rubbing the plastic on here. Positive, repel. And negative, positive, attracts. What else? What else? Chamath was upset about it. Chamath was telling, no sir, sometimes positive also attracts. I'm talking about charges. Positive repel, negative repel, negative, positive attracts. Right? So, how they attracts? There is a positive charge. Okay. There is a positive charge and there is another positive charge. They repel. Say this is A, this is B. This is force acting on A by B. This is the force acting acting on B by A. Tell me. Hmm? No, I don't know whether they are in equilibrium or not. They may move. Right? They may move. My point is, this is Newtonian physics. What Newton said, I mean, not Newton, but that's a Newton's concept. Force acting on A is given by B. And Newton himself at a point saying, this is absurd, creepy. Not for this specifically, if I'm not mistaken, for Newton's law of gravity, he said. මතකද අපි gravity උගන්නන්න කියනවා you and you attracts, that's creepy. Not that mental attraction we are talking about, physically, the force exerting on you. Force exerting on you by someone else. Someone else. Absurd. So yes, later the lessons develop, if I'm not mistaken again. With the history, I'm a bit, I'm interested about the parts of, I'm very bad at these dates and, the times and stuff. So it is Faraday, if I'm not mistaken. Faraday is the first one who brought this idea of the field, magnetic and electric idea, field lines idea specifically, and he said, no. This is not directly taken place. That is a modern physics idea of field. Positive charge creating something called what? Field. There's a field. The body is not directly exerting a force on the other body. It is the field which works. Right? Field. So I create my own field, my territory. So when you interact with my territory, my field exerting a force on you, the effort is coming from the field, not from the object itself. ඇත්තනේ creeping දැන් මට මම මෙතන ඉඳන් ඔයාලට මෙහෙම කරනවා කියන්නේ okay, I'm exerting a force. Marvel movie එකක වගේ. අතිනේ එහෙම කරන්නේ. Say get the අන්නේ යන්න ඕනේ මොකක්ද අනේ ඌ ටිකක් පහුවෙලා ගියේ ඌ ටිකක් කල්පනා කළා හා එතකොට එහෙම වෙන්න බෑනේ එහෙනම් කොහොමද වෙන්නේ but yes I can have a field which is having my power, my region, my force, my effort, my control, something, my fame, whatever that field, region. So when you interact, when you enter to that my region, the regional effect is creating on you, that is considering as the force field, force due to the field. So this is not directly Newtonian physics එකේ වගේ අපි මෙහෙම ලියන්නෙම නැති තරම්. Electrostatics වලදී අපි tension ඒවට මෙහෙම ලියනවානේ. So we are not writing like this most of the time. We keep it force exerted on one. If intermediate technique intermediate technique. Force acting on A by a field generated by B, force acting on B by the field generated by A. So we are going through the intermediate personality, intermediate region, intermediate concept called field. Is that clear? Right. So let's go through the slides a little bit. Like charges repel, unlike charges attracts. History part එක තමයි මේ තියෙන්නේ. Yes, electrostatic field. To understand this, we need to learn 4 concepts in the first session. That is electrostatic force, electric field intensity, electrical potential, and electrical potential energy. These parts are basically for 6.1, 6.3. So electrostatic force. Before we go to the topic, I like you reading the note, underline, highlight, and finish studying the part. Okay. So only one question there. That is, what is mean by the conserved, about conservedness, conservativeness of electric field? We are coming to that in the third session today. So till that, we'll hold it. Conserved means field cannot be destroyed or created by any other source, because his field belongs to me. My field is for me. No one can, you can interact with it, but not destroy or create. That's the idea of it. So we'll go for that conceptual part a little bit later. We have that flux model 6.2. So the second session, right? Coulomb's law. Very simple theory. Focus on the screen. The attraction or repulsion force between 2-point charges is directly proportional to each charge and inversely proportional to the square of the distance between them. Right? Very simple. Study this. The attraction or repulsion force between 2-point charges is directly proportional to each charge and inversely proportional to the square of the distance between them. So happily and generally, we don't have to remember these laws in physics. This is very tricky. Because සමහර අයට තේරෙන්නේ නැහැ මේ කිව්වමත් පොඩ්ඩක් හරි මිස්කන්සෙප්ට් කරගන්න මම කියන එක. එකක් තමයි, you don't have to buy hard this as it is. See, that is better phrasing. You don't have to buy hard this as it is. You don't have to buy hard this as it is. Okay. But you should know the meaning of it. In a way, for that you need to remember. The by-hearting and remembering are two different things. When you close your eyes, you need to get this feeling. Force, electrostatic attraction or repulsion force. Key points: electrostatic force. It can be either attraction or repulsion. Right? And is directly proportional to what? Two charges, magnitudes of two charges. Charge එක value එක, physical quantity value එක, Coulomb value එක. Directly proportional to that and inversely proportional to the square of the distance. Inversely proportional to the square of the distance. So, yes, well, as usual, I told you I do this with the sentence, the diagrams, as well as equations. So, we'll get the format. Attraction force. Attraction, so they may move towards each other, right? And similarly, repulsion force, they move away from each other. So either attraction or repulsion, right? Visualization of the idea. And that is, I have marked both forces, but remember, don't misconcept the idea. We don't have two forces, either the attraction one or the repulsion one. When the attraction is there is no repulsion. When the repulsion is there is no attraction. Because similar, that's why I get plus or minus. I brought this into a kind of one figure, rather drawing 3, 4, plus Q, minus Q, minus Q, plus Q, minus Q, minus Q, plus Q. So all 4 figures are on the same same figure, same diagram. Yes. It is proportional to Fe proportional to Q1, Fe proportional to Q2. Therefore, you can take it together, or inversely proportional to R squared. So Q1, Q2 over R squared. Grade 8 mathematics. Direct proportionality and inverse proportionality. When one factor proportional to Q1, Q2 another factor, two factors, so you can get the product. Y proportional to X, Y proportional to Z, Y proportional to X into Z idea. That's a grade 8 mathematics. So you put the proportionality constant to remove this. K. There are so many things we need to learn about K. I will tell you in the third, fourth sessions today. So this proportionality constant K is little bit complicated. And can you remember the way we found these proportionality constants? Proportionality constant. One, yes, proportionality constant can be found either experimental procedures. Two, dimensional analysis we can't. Experimentally, experimentally, yes. Two, mathematical models. Three, by defining unit systems. Newton's law, F equals ma. How do we remove proportionality constant K? By defining Newton. Next couple of weeks you are learning Tesla definition. Similar. Jamat, yes. Tesla vehicles. No, not Tesla vehicles. So we are talking about magnetic field. That's the Tesla name coming from that as well. Yes. So, so here in this case, K is taken in terms of a kind of a mathematical model. So that modeling part we are learning today at the latter part of the lesson. Right. It is given as 1/4 pi epsilon. How do you pronounce this? Epsilon or epsilon. You can, use some accent. Epsilon or epsilon, right? Greek letter. අපි සිලෝන් හින්දා අපි එප්සිලෝන් කියමු කියලා. රයිට්, හරි එහෙම කියමු. Epsilon. Ideas. Epsilon, ඒ නිසා epsilon. Okay. Hence, the Coulomb's law equation becomes what? Fe 1/4 pi epsilon epsilon Q1 Q2 over R squared. Yes. So Fe is the electrostatic force between two charges. R is the distance between two charges. Q1, Q2 are the magnitude of two charges. So only term I have not defined here in this screen is epsilon, because it's in the next screen. That's the key part. Idea එක මතක තියාගන්න. මේකත් අර හැමදාම කියන වගේ lesson එකක්. ඒ කියන්නේ when I teach this lesson, you will keep listening to me nicely. You will keep listening to me nicely, and you will wait until I finish explanations. You are very happy. Okay. So yeah, giving the attitude that you understood this. And when I finish this, what you're going to do? when I come to you and ask, did you understand? Yes sir, yes sir, yes sir, yes sir, yes sir, yes sir කියලා ඔක්කොම කියනවා. කියලා වෙලා අන්තිමට කියනවා. But sir, what is really epsilon? Reason, this some physical quantities are not tangible. You don't feel it. තාම අපි ෆිසිසිස්ට්ලා වුණාට අපි අර ෆීලිං එකයි අපි ඔළුවේ තියෙන්නේ. Not the logical sense of it. We want to feel it now. Force we feel. Temperature we feel. Do you understand what I'm telling? Speed you can see. You experience. But these things you don't experience. You know the reason. To experience this electric field or magnetic field or something, you are not an electron. Who experience the field? Charges. But you are not a charge. When you are not a charge, you don't experience this. Permittivity of the medium is something similar. You don't experience. You don't experience, very mathematically, scientifically, but not practically. You don't experience. You, in a way, you observe thinking beyond this. In a laboratory, you can experience, yes. And you can not when you're staying like this. Light you experience, sound you experience. Electric field is not something like that. So the permittivity is something similarly to this. Why? Permittivity. Permittivity is the measure of the spread of electric field through the medium. That's how I like to start the discussion. Permittivity is the measure of spread of electric field through a medium. In other words, when the permittivity of a medium is high, electric field in the medium is weak. On the other hand, when the permittivity of medium is low, the electric field is strong. Let's take this. Let's take this. Whenever I try to explain this permittivity idea, the only thing comes to my mind to feel this is the refractive index. Refractive index idea. And you don't get the refractive index directly. Why? You can't see a refractive index. But you see some other situations, other activities. One, when a light ray travels through it, it bends. If you can measure the speed, speed is high in low refractive index. Inverse. Less refractive index, speed high. High refractive index, speed less. So you understand the refractive index based on what? Speed of light. Similarly, you understand, not experience, you understand the permittivity. Permittivity is a medium property which decides how strong, how weak the field is. When the permittivity is high, you can see through the equation as well. When you look at the equation, you can see what? It is inverse relation there. Right? When the field is more, tell me, the field is more, the permittivity is low. When the permittivity is high, field is weak. How do you recognize a field? By understanding the force. When the force is weak, field is weak. Sensible. Okay, that is the beginning of it. Right? The quantity epsilon is called as the permittivity. It has a value depending on the medium surrounding of charges. The lowest permittivity of, or the highest strength of the field is for the vacuum. Vacuum permittivity is given as epsilon naught. Epsilon naught is 8.85 into 10 to the power minus 12 coulomb squared per meter squared per Newton. Right? Now you put these values and gonna find what? The proportionality constant for the vacuum. The strongest field is always the vacuum. In vacuum, the reason, no disturbance of particle kind of a feeling. So the smallest refractive index is, smallest permittivity is for vacuum, epsilon naught. Right? So 8.85 10 to the power minus 12. So these numbers you don't have to buy hard because they're giving the numbers. They're giving the numbers, right? So 1 over 4 pi epsilon naught. We put the values and we get it approximately 9.10 to the power 9 Newton square meter per Coulomb square. Right? And then now we know the relative permittivity idea. These are easy. So dielectric constant. So you can go for the dielectric constant or relative permittivity. So you know that now when you are closer to the exam, like 5-6 months closer, I'm not planning to teach these kind of things. This is like relative density. You are comparing two media. Media is compared to the vacuum, the smallest one, right? So epsilon is the permittivity of a medium, any material. So this is for the vacuum, and you divide these two, or you cross multiply and get permittivity of any medium is given by what? K, the dielectric constant into epsilon naught. Okay, is that clear? Right. Okay, just go through it and read it. Any questions? Any questions? Any questions? Right. Okay. Now, electric field strength. Electric field strength. He's asking in the book we have superposition part. Yes, we are coming to that. සාමාන්‍යයෙන් මම ඒක උගන්වන්නේ වෙන formats වලට. ඔය note එක හදලා තියෙන්නේ syllabus order එකට. So book එකේ තියෙන්නේ syllabus එකේ order එකට. So you have to go through the book. Whoever purchased the book, outsiders, so they have to go through the syllabus order. But my teaching order is different, which is more convenient and interactive because now we have to do sums. Right? In a while we are taking it. Yes. Now, there are two charges attracting each other through the field. Field is supporting this interaction, right? And the thing here for the idea how big B's field is, how big A's field is. How big B's field is, how big A's field is. Force depends on both. Force depends on both. Understood? But field, is it depending on the other one? Like my field depends on your field? No, my field can interact with your field, but my field depends on my properties and what else? What else? We'll go to this. So to do that, electric field strength or electric field intensity electric field intensity, right? Or how strong the field is. How strong the field is. About what? About what? How strong the field is about the field generating charge. And one more factor, that is right. So let me explain this idea simple form. F is 1 over 4 pi epsilon Q1 Q2 over R squared. Right? Now I want to check the strength of the field. I want to check the strength of the field. So to check the strength of the field, to measure the strength of the field, what I do, I have to keep the second one out of the process. Because I want to check what? Only my field. So the best way to remove Q2 is? Consider it as one. Simple. They know. This is the same thing what we do in physics everywhere. So what we do is define, okay, take Q2 as 1. So now tell me the definition of electric field strength. 2 lines. Rashmi pota කියවන්න එපා. පොත වහන්න. උගන්නන වෙලාවට පොත වහන්න. Thinking part එකනේ ඕනේ thinking. This is thinking time. When I ask a question, පොත බලනවා කියලා කියන්නේ ඔයා හිතනවා නෙමෙයි. පාඩම් කරනවා. කටපාඩම් කරලා physics ගොඩ දාන්න බෑ. Now I have given an answer here on the screen, on the board. You tell me how to define the strength of the field. No, I'm asking a definition. In definitions of quantities, we don't go for proportionality parts. You have to develop. I know that you are going to develop this. Very good. Electric force, electrostatic force exerted by unit charge. On the only the prepositions are wrong. It's not by. On. Very good. Electrostatic force acting on unit charge by me. Q1 is my field. So electrostatic force is, can you remember our technique? Electrostatic force is electric field when Q2 equals 1. So electric field intensity is a force. Electric field intensity is a force. Electrostatic force acting on unit positive charge. Unit positive charge. Simple. So we'll go for the proper definition, right? Yeah. Electric field strength is a measure of the field. Yes, the electric field strength at a point is equal to the electrostatic force acting on a unit positive charge at that point. So simple idea. So we take the test charge. Test charge is the opposite one, the other one, not me. Who is generating the field? I generate the field. I generate the field. Q generate the field. Always think about your point of perspective. So Q generate the field at the test charge. What is the test charge value? It should be, simple Q should be 1. By definition, okay. Force acting on simple Q charge is Fe. Force acting on unit positive charge is Fe over Q. That is E. Either E equals Fe over Q or Fe equals EQ. Simple. Unit wise, you get Newton per Coulomb. And yeah, Newton per Coulomb. And then Fe equals EQ. Remember the two varieties because we always define this for unit positive charge. Therefore, what is the possible variable number 3 here? Now there are two variables. What are the two variables? What are the two variables? Q, main Q, the field generating charge, and R, very good. And there is a hidden variable. The Q can be not only the magnitude but also the sign, the type. It can be either positive or negative. It can be either positive or negative. So Q can be either positive or negative. So you understand when it is positive, the force is away. When this is negative, force is towards. Because attraction, repulsion, what we have learned in grade 10. So E equals 1 over 4 pi epsilon Q over R squared. Because force is 1 over 4 pi epsilon QQ over R squared. On the other hand, EQ equals 1 over 4 pi epsilon QQ over R squared. So simple Q cancels. E is 1 over 4 pi epsilon Q over R squared. Now what was the force formula? What is the force formula? Force formula is electrostatic force equals 1 over 4 pi epsilon Q1 Q2 over R squared. What is the electric field formula? 1 over 4 pi epsilon Q over R squared, because it's only one charge. The charge which is generating the field. Simple Q is there in the other expression, second expression. F equals EQ, simple Q. Simple Q is about what? Field, not the field generating charge, but the test charge. Is that clear? Right, okay. Go through the note completely. Now we are almost done with the first session and we are going to go for questions. People who are joining the live sessions online, please get the PDF by dropping a text to the hotline. this. Right. Okay. Now there are two good questions. One, the Abhita's question, that is, I'll drop it in this way. Now she's asking, what if the other charge is not? What if the other charge is not a unit charge? What if this charge is not a unit charge? Actually, electric field is not for the charge. So we are searching for B. We are concerning about B. Like for an example, I redraw B here to distinguish this idea, B, with charge capital Q, right? And we are talking about a point A. Now A is a point, not a charge. We define electric field at point A. We define electric field at point A. Even though there is no charge at A. Even though there is no charge at A. You got this? When there is a charge, that is called force. Force is on a charge. Field is at a point. Now, why are you confused? Because we keep a test charge to measure the force. Without measuring the force, you can't get a physical quantity to measure it. So we measure the force at a point by keeping a test charge. Now, if it is just a point, we don't have a test charge here, what will happen? You can't measure the force. To measure the force, you have to keep a test charge. When you keep a test charge, you experience the force. When you experience the force, when you see the force, when you observe the force, we measure the force and then we have a force on a test charge. You divide by the test charge to obtain the force on unit positive charge. You got this? Clear? So I drop it to one line. Electrostatic force is on a charge. Electric field intensity is at a point by a charge. So therefore, you don't have to have the test charge always at point A. But to define it, you need to measure it, you need to keep a test charge. So that test charge must be unit positive charge. If you don't have a positive charge, we keep a simple Q charge and measure it and calculate it to unit positive charge. Understood? Right, so, sorry, I forgot the question. So, another question, when do two charges attracts, can they go there and hit on each other? That's a little bit complicated. We have to go a little bit further with the nuclear physics parts. Now, say for an example, proton and an electron. So can you project an electron towards the proton and let them attract and collide? Bit of particle physics. We'll take it in 11.8 particle physics lesson. We'll keep it for, because this is a little bit Newtonian, you understand. This is a little bit conventional physics. We consider charge as an individual macroscopic body. Right? So that is a little bit bigger concept. We're going to take it for sure. And we'll try to do a video on that as well. Okay. Right. Shall we go for the questions? Some people ask where the hotline and how to get the tute. Online people, so please go through the description of the video and you will find the numbers and text the number and you can get the PDF of relevant parts what we do today. And if you really want to buy the book, you can contact the publication number as well. All are there in the description section. Right. Even you don't want, if you don't have the PDF right now at the moment with you, online people you can see the question on the screen, and you don't have to write down the question. Just start the. Actually, these are not questions; these are examples to practice the equations and all. So quickly do them, and you can upload the answers to the WhatsApp groups or WhatsApp group. So please. Online people can send the answers in the WhatsApp group so we can correct your answers as well. ඔයා ඉන්නවා අනින් කන්දාලි ලස්සන තාක් කරගලා වාරි තුනි වලට මම පිළිවෙලට වැඩ කරලා මුණක් තවලා නේ public phone Meanwhile, you can collect all the previous papers except the papers you plan to write. Okay? So anyway, only up to unit 2, paper number 8. Right? Paper number 7. Paper 8 onwards, we are not writing the second round. The people who miss the papers, we don't write it from unit 3 onwards. Rewriting sessions are not available. Right? එහෙම දැම්මොත් එහෙනම් මොකද වෙන්නේ? අන්තිම හරිය papers rewriting ටික දෙන්න වෙන්නේ second try කරනකොට. Right? So එහෙම නෙමෙයි. So this is basically for you up to say paper number 7. Anything else you can collect today, and today is the last day to collect because we are going to destroy the papers. Right? Okay. Let's go through the questions. The question is, number 1, the question is, charge of 5 plus 5 microcoulomb is kept in vacuum. Find the electric field intensity for the value of x equals 1, 2, 5, 10, etc., etc. So we find the values, very easy, it's a repetitive model. Now this is how I approach the repetition models. I don't know whether you figured that. Now you need to understand the repetitive models. One, you need to save some time. How to save? First of all, the common fact. So 1 over 4 pi epsilon is 9 into 10 to the power 9. Q is this. R is this. So you get the value in terms of x because given in centimeters. Then we substitute the value and get it for E. E1 is 4.5 into 10 to the power 8 Newton per Coulomb. People who got this answer, raise the hand. Right. Keep. Right. Okay. So then, this is what I do. I don't do what you do. I do something different. Now that is the concept. Because when I find it for 1 centimeter, distance is twice. So what I have to do? Divide by 4. Because that is what Coulomb said. Coulomb said it is inversely proportional to the square of the distance. So that's why this is not merely substituting and getting answers. So 5 centimeter divided by square of 5. And you got these two answers. I have left it for 2-3 extra decimals. You don't have to do the same. We'll see the numbers later. People who got these two numbers right, please raise the hand. Right. Okay. 10 centimeter divide by 100, 50 centimeters divide by 2500, and people who got these two numbers, People who got these two numbers, okay, everyone got the numbers right, very good. So I'm waiting for the online people to work. Right? 1 meter. So now it drops down to 10 to the power 4, and 100 meter it dropped down to 4.5. Now you have a challenging work. What is it? Draw the graph. Think smart and draw the graph. Think smart and plot the graph. You can't ask questions. Plot the graph. Plot the graph. Right. Right. So how to plot it? So you can see I have gone maximum up to what? 10. We can't go beyond that, right? Maximum 50, can you? I don't think we can go 50. Neither. Yes. Sorry, here 0. Meters, stupid. Why? Why not meters? It's only one figure in meters. It's only one figure in meters. So ignore all the other values and go for meters aparade. So ignore meters and go for the centimeter figures. And then what I try to tell you, because that 100 meter is the infinity. Because you start with 10 to the power 7, 8 and you get 10 to the power 1. So it's million times smaller. The electric field is negligible. So that's how the asymptone works. It is tends to infinity. So x tends to infinity, electric field tends to 0. So we call asymptones. Right. Right? Any questions? You can ask questions now. Any support you want? Any help you want to plot the graph? Right. So we can go for the break. we can go for the break. Right. Right. Let's go for the break. Start in 20 minutes. You can collect your last week papers as well today.